All right, so today we're going to finish our notes with inverse variation. So if you remember, direct variation was y equals k times x, right? And I told you k is kind of like slope. Well, the inverse of something is the opposite. So if we're going to do the opposite of multiplying k and x, then we're going to end up dividing k and x. So that's kind of why your inverse variation equation is this, y equals k divided by x. You could also think of the inverse of multiplication as like a fraction. So if I have y equals k times the inverse of x, that's really what's happening. So here we have y varies inversely as x if there is some non-zero constant k, such that y equals k over x, where x is also not be zero because it's the denominator. K is, again, called the constant of proportionality or the constant of variation. So you might see it called either one of those things. Whoops. All right. So for our first example, we're going to work these the same as yesterday. If you can find the constant, then you can find any x for any y you're given or any y for any x you're given. So we have to find the constant first, and then we can move from there. So if I tell you that x varies inversely as y, if x equals 4 and y equals 6, find y when x equals 12. So I know that I have an inverse variation. So I know first I'm using the equation k divided by x. Okay, now I also know this pair. I know that when x is 4, y is 6, which is the same as saying I know this ordered pair. I have an x and a y that's working together in this equation that I've given. So if I can find their k, then I can move from there. So if I plug in what I know, so y is 6 equals k divided by x is 4. I need to find k. So to break up the fraction, I'm going to multiply by the denominator so that it cancels and leaves me with k, but I have to do the same to the other side. So k equals 24. So in this entire problem, no matter what x or y I'm given, I know that they vary as a fraction where the constant is 24. So I can take now this information where x is 12. In step 2, I can use my k to find what y has to be because it's going to follow the same pattern. So if I have y equals, we found k to be 24 divided by x, and I'm telling you that x is 12. So y equals, 24 divided by 12, so y has to be 2. So when x is 12, y is 2. So we just found x's pair. We just found the pair for when x is 12. So again, you're finding k so that you're finding the pattern or the constant or the proportion, and then you use that same proportion to find any other point in the problem. Okay, this next question is kind of long and worded, but on a string instrument, the length of a string varies inversely as the frequency of its vibrations. The vibrations are what gives the string instrument their sound. So again, I have an inverse situation, an inverse variation. So I know I'm dealing with the equation y equals k over x. First step. Okay, now, an 11-inch string has a frequency of 400 cycles. So this is a pair. This goes together. So I can say, let's change these letters to say that the length of the string and a frequency f. So instead of y and x, let's use L and f. So really we know that the length of my string is going to vary inversely with the frequency. Okay, so now we're going to plug in what we know. We're going to plug in that pair, 11 inches, some constant divided by 400 cycles per second. Okay, now, in order to find k, I'm going to multiply by the denominator. So I know that k equals 400 times 11 is 4,400. Okay, this is the constant that's going to work for anything in this problem. So we now know how this length of the string varies with the frequency. We know the variation, we know the proportionality, so I can use that proportionality to figure out what happens if I have a 10-inch string. So I know that the length of the string varies proportionally with the frequency. I know that the proportion we have in this situation is 4,400 cycles per second divided by the frequency. They're telling me I have a 10-inch string, so the length is 10. It's equal to 4,400 over F. I need to find F. But because F is stuck in the denominator of a fraction, I have to break the fraction up first. So if I multiply by F, that leaves me with 4,400 on the right-hand side of the equation and 10F on the left. So now I can divide by 10 to find that F equals 440. So there's a real-life application to this constants in proportionalities that we found. And that's it.